We were looking at jointly distributed discrete random variables. We looked at the joint PMF. We looked at how we can answer probability questions for X and Y using the joint PMF. Then we looked at how we can find the marginal PMF of X and Y from the joint PMF of X and Y. Now we want to look at how do we find expected values of functions of jointly distributed discrete random variables. So here expected value gxy, where gxy is that function of the jointly distributed discrete random variables x. Over here, what you do is you sum up over all possible ordered pairs xy, gxy times probability capital X is small x and capital Y is small y. So essentially what you're doing is for every possible ordered pair xy, you evaluate where the function value gxy is and multiply it with the multiply it with the joint probability of that ordered pair, probability capital X is small x and capital Y is small y. And then you sum these terms for all ordered pairs, right? So if take every ordered pair xy, evaluate gxy for it, evaluate with the function value gxy is for that ordered pair, multiplied by the joint probability of that particular ordered pair, and you then sum this up for all possible ordered pairs. Right? If you look at an example, and this will make more sense then. So here's the two things that we definitely do want to know. Okay, if this function of x and y, right? So this is like expected value of any function of the jointly distributed discrete random variables. If this function of gxy is just equal to x, right? This is a specific form of gxy. What if this is just equal to x? If this is just equal to x, then if this is just equal to x, then we have just x over here. And what this will do is this will give us the expected value of x, right? If I just take a specific form of gxy as x, then I can use the joint PMF to find just the expected value of x. Right, so given the joint PMF of x and y, we can actually find expected value of x in two ways. One is that you can just use the joint PMF where you just let gxy to be equal to the specific form x. So over here, what you do is for every possible ordered pair, you evaluate gxy, which is just x, multiply with the joint probability of that ordered pair and add them up. There's another way you can also find expected value of x given the joint PMF, where instead of directly using the joint PMF of x and y, you first use it to find the marginal PMF of x like we learned before, and use that to find expected value of x. Because remember what the marginal PMF of x is, it's giving us the values of x along with their probability. So this way, so approach two of finding uh, expected value of x is similar to how we find expected value of x for a function of one random variable, where we first use a joint PMF of x and y to find the PMF of x. But we don't have to do that. We can even find the expected value of x without needing to find what the marginal PMF of x is by just directly using a joint PMF of x. By just taking this gxy in this formula to just be equal to x, right? So we can do that. We look at an example for this. Now, similarly, if gxy is just equal to y, this is another specific form of gxy. This will give us expected value of x. So if we want to find expected value of just x or expected value just y and not really a function of x and y, we can still do that using the joint PMF of x and y without having to find the marginal PMFs of x or y. So using joint PMF of x and y, we can actually find expected value of x of a function of just x, like expected value of x square, say, expected value of x cube, and so on, of just y, like expected value y, function of just y, like expected value y square, or a function of both x and y. So basically, joint PMF of x and y can be directly used to find expected value of not just a function of both x and y, but even expected value just functions of x or just functions of y without having to find what the PMFs of x and y are. So remember to find expected value of x or of a function of x. So one approach is we can directly use the joint PMF without needing the marginal PMF. Alternatively, we can also find the marginal PMF of x using the joint PMF and then use that to find expected value of any function of x. Similarly, we can use the joint PMF of x and y to directly find the marginal PMF of y without having to find we can use the joint PMF of x and y to find the expected value y without having to find what the PMF of y is. But alternatively, we could have found the PMF of y from the joint PMF of x and y and use that to find expected value y, but we don't have to do that. So let's look at this example. So the joint PMF of the discrete random variables x and y is given as this. Now in this example, let's find expected value of x. Like we said, we can directly use the joint PMF of x and y without having to find what the PMF of x is. So recall, we said expected value gxy is that we sum up over all possible ordered pairs gxy times probability capital X small x and capital Y small y. So when we're finding expected value of x, we take a specific functional form of gxy, which is just simply x. So expected value of x is just summation over all ordered pairs xy, x probability capital X small x and capital Y small y. So here this gxy is just simply small x. So what we're going to do is we're going to find this for every possible ordered pair. So if we go back, the first ordered pair is that x takes a value 0, y takes a value 1. So we evaluate gxy, which is just equal to x for this ordered pair. So it's just 0 times the probability of this ordered pair 1 by 4. This is what we've done here, right? So for the first ordered pair 0, 1, we evaluate what gxy is, and gxy is just x here. So we just take the x value 0 and multiply with the probability of this ordered pair. The next ordered pair is 0, 2. If we go back, so x is 0, y is 2. Again, the x value for this ordered pair is our gxy, which is 0, and the probability for this ordered pair is 0. Right, this is what we've done here. We have this ordered pair 0, 2. So we evaluate gxy, which is just x for this, which is 0, and we multiply with the probability of this ordered pair, which is 0. Then we take the next ordered pair, where x is 1, y is 1, and the probability for this ordered pair is 1 by 2. So we know for this ordered pair x is 1, y is 1. So we evaluate gxy, which is just x, which is 1. And we multiply with the probability of this ordered pair, which is 1 by 2. Then we take the last ordered pair here, where x is 1, y is 2. And the probability of this ordered pair is 1 by 4. So here, we know for this ordered pair x is 1, y is 2. So we take gxy, which is just x, in this case 1, and multiply with the probability of this 1 by 4. So this is how we can find expected values of x. An alternative approach was that find the marginal PMF of x from joint PMF of x and y and use that, but you don't necessarily have to do that. You can also find expected value of x directly using a joint PMF like we just found without needing to find the marginal PMF of x, right? So we can also find expected value of x where similar to expected value of x using either approach. Approach 1 is use the joint PMF of x and y. Like we said, expected value gxy is that you sum up over all possible ordered pairs gxy into probability capital X small x and capital Y small y. Now, when we are finding expected value of x, gxy was x, but now when we're finding expected value of x squared, this function of x and y is just simply x squared. So this is how then we can find expected values of x squared. We again go back and sum up over all ordered pairs. So the first ordered pair is x is 0, y is 1, and the probability of that is 1 by 4. So for the first ordered pair, x is 0, y is 1, right? And so here we evaluate gxy for this ordered pair, which is just x squared. So it's 0 squared into 1 by 4. When you are finding expected value of x, remember gxy was x, so we took 0 here, although 0 squared is the same as 0, but just highlighting, obviously if it is a different number like 2, then that would have mattered. Right, so ordered pair, x is 0, y is 1, so we take x squared and multiply with the probability of that ordered pair. Then we go back to the next ordered pair, which is x is 0, y is 2, and the probability of this ordered pair is 0. So x is 0, y is 2. So we evaluate gxy, which is x squared for this ordered pair, and multiply with the probability of that ordered pair is 0. We move on to the next ordered pair, where x is 1, y is 1, and the probability of that ordered pair is 1 by 2. So here we know the ordered pair is x is 1, y is 1. So we take x squared for this, which is 1 squared, times the probability of this ordered pair 1 by 2. Then we move on to the last ordered pair, where x is 1, y is 2, and the probability of that ordered pair is 1 by 4. So x is 1, y is 2. So we take gxy, which is just x squared, for this ordered pair, which is 1 squared, times probability of this ordered pair 1 by 4. So, and alternatively, we could have also found the marginal PMF of x from joint PMF of xy and use that to find expected value of xy. But we don't have to do that. We can find expected value of any function of just x or any function of just y using the joint PMF of x and y without having to actually find the individual marginal PMFs.